error handling. So, as we have studied exception handling in C++, similarly, we have some predefined functions for error handling in Solidity. So, generally, what happens in a Solidity code, whenever there's an error, the state is reverted back to its original state, which means that if there's an error, whatever changes that function is trying to make will not be done. It would be rolled back to the previous stage. So, basically, error handling functions we use in our code to prevent any unauthorized access to codes. So, how to perform that? There are three methods we can use. These are all predefined methods in Solidity. The first method is assert, which takes an Boolean condition. So, in case if the condition which you have put inside the round bracket is not satisfied, so this method call causes an invalid opcode and any changes done to the state variables gets reverted back. So this is mostly used for internal errors. Next is require. So assert and require, the syntax resembles a lot. So mostly they are same. But there's a major difference between assert and require that we are going to see through code example. So in case of you're using require for error handling, if the condition that you write is not satisfied, so this method calls revert to the original state or the previous state. So this is mostly used for errors in inputs or external components. Whenever there's an external interaction with the contract, require is used. The last function is revert. So as you see that revert doesn't takes any argument as input. So this method reverts any changes done to the state, to the previous state, but it doesn't checks any condition explicitly. So these are the three methods that are used for error handling in Solidity, or you can say exception handling as well. Assert, require, and revert. Next, we are going to look at the code, simple code examples of how to use these methods in our code. So let's first look at the require method. So what does require do? It checks the condition and returns the gas fees if the condition is false. So we have studied that in order to execute every function, some gas fees is mentioned for executing a function. So if the condition which is you are checking through the require, if it is failing, it would return the gas fees back. So let's look at a very small code example just to understand the syntax and functionality of require. So I have written a contract require test in which I have initialized a variable marks to 100. Then I'm writing a function test require to which I'm passing an argument marks. So this MKS would be the user input and I'm returning uint. Okay. So what is the condition I'm putting here is require the Boolean condition that we have seen in the syntax. So the Boolean condition would be, I have put in that the mark should be greater than 40. So if this condition is met or it is true, then only the rest of the code which is written inside test require function would be executed. Otherwise, it would revert back and the rest of the function code won't be executed. And it will just display an error message saying that the marks are below a certain level. So if you're using require, what will happen if the condition is failing? Okay. So it will print this error message and it will return the gas fees also, which was utilized for calling the function. Next, use of assert. So assert is basically used for checking rare conditions, and even if the condition fails, no gas is returned. So let's look at the same example. So I have put in the same code. I have initialized some marks value to 100 and I'm using assert as a error handling function inside test assert. and simply checking the same thing, that is marks is greater than 0. Otherwise, this error message would be printed and I'm returning marks. Now, if you just closely observe, there is no difference between how you write require and assert. The only difference is in the functionality, how assert and require revert. So basically, assert revert with returning the gas, not returning the gas fees, whereas require reverts with returning the gas fees. So this is only the major difference. Rest, the syntax of writing the require and assert remains the same. The last method, which is revert, this error handling method is used for only checking the validation part. So you do not write any condition here. So just observe this piece of code that I have written. So there's a contract error revert test, initialized marks to 100. Then I've written function test revert, to which I'm passing an argument MKS, and this returns an unsigned integer value. So since revert doesn't takes any arguments, so how will I write the condition? So in that case, I have to write the condition using if else statement, or it may be if else if ladder also, depending on what logic I'm implementing. So simply I've written if marks is less than 10, revert, else return marks. So this revert is not going to print any message. It is just going to say that the condition did not meet and the function has reverted. Whereas in the above two cases, that is assert and require, we were displaying some user given messages, error messages, which will be displayed if the condition is false. So this is the major difference between the three error handling methods which are present and their usage, small examples. So in the coming code examples, we'll be using these methods for error handling. Next, there is a concept called as fallback function. So we have looked at what is a normal function, but now we need to look at what is a fallback function. So a fallback function, as it is defined, it's a special function which can be written inside a contract, but it has some specific features. So a fallback function gets called when a non-existent function is called onto the contract, which means that the fallback function does not have any name, and compulsory to mark the fallback function as external, because mostly the fallback functions are called by external contracts, not by methods written or the functions written inside the same contract. So this function does not have any name, it does not have any arguments, and it cannot return anything. And one contract can have only one fallback function. So these are certain constraints on how fallback functions could be written. So if the fallback functions are not marked as payable, it will throw exceptions. Okay, so it is compulsory also to mark the fallback function as payable. Payable is again a keyword in Solidity, which is used to define a function which is going to receive cryptocurrency. Any function which is sending or receiving cryptocurrency has to be marked as payable. So if it is not marked as payable, it will throw an exception if the contract is receiving plain ethers without any data. So with fallback functions, you can send ethers as well as you can send some data also. So these are the properties of fallback functions. Majorly, no name, no argument, does not return anything, and one fallback function can be written per contract. Let's look at a code example for the fallback function. So if you just observe here, I've not written anything complicated. I've just kept it simple to just declaration of the function. So I've written a contract fallback example, and inside that there's a function which is marked as payable. This function doesn't have any name. So this function is not having any name. It's just the keyword function, no arguments, no return types, and it is marked as payable. And inside this function, I can send data, or with the function, I can also pass ethers from one contract to another. So in this, I'm passing data, which is just initializing a variable to some value. Okay. So fallback functions are very important when you are writing contracts which interact with other contracts, because a fallback function can actually be used for calling functions written in another contracts also. So we'll see the usage into code for fallback functions also. Now, coming to smart contracts. So this example I've already taken some other example in unit 3 that we have taken in the theory classes. So smart contracts basically can help ease any kind of real world use case like a property transfer. So there would be a registry in which registry as in a backend database which stores all the information about the different properties which exist. This smart contract will actually match the buyer and seller. So depending on this, whoever agrees to do the agreement, the contract receives assets from the buyer, and then the contract would distribute those assets to the seller. So in this way, without any intermediary, the seller and buyer can actually sell and purchase property. Also, the properties which are recorded as sold from a person A to B on the blockchain cannot be manipulated, and hence forging of documents or forging of deals could not happen if such use cases are employed in real estate. So two major benefits of doing this, that is the ownership of the property would be undisputed, because even if this property goes through a chain of buyers and sellers, the blockchain would record each and every buyer and seller in the process, who was the first, second, and so on, as the ownership of the land or property. Clearance and settlement would be automated, because no manual intervention or third party intervention required. Assets would be distributed in the form of ethers, if we are considering the use case of Ethereum blockchain. So here I have put in directly the code image which was available, but we're not going to take it right now, because this involves a lot of functions and a lot of modifiers and a lot of concepts together. So this I'm going to take at the end when I complete with taking all the basic examples of code. So right now we're not going to take it. Here on unit 4, there are certain practical assignment questions that I have put it in the PPT. And this we are going to solve in the offline lecture when we meet tomorrow. So this is basically kind of a hands-on practice of writing your own smart contracts and deploying those smart contracts onto the test networks. So we'll do it with both, either using MetaMask or using Remix VMs. So a quick introduction to the Remix IDE. So Remix is basically the IDE for developing smart contracts. It supports the Ethereum virtual machine, which is responsible for converting the solidity code into byte code, which the EVM or the other applications understand. So this is a powerful tool set which has all the integration present, like developing, deploying, debugging, and testing Ethereum and any EVM compatible smart contracts. So coming to ERC20 token. So this also has an implementation, like we can also create our own ERC20 token. But before we do that, we need to understand what is ERC20. So ERC20 stands for Ethereum request for comment, and 20 is the standard number. So before understanding what is ERC20, we need to understand what is a token first. So token basically can actually represent anything on the Ethereum blockchain. It can be the reputation points in an online platform, or it can be a skill of a character in a game if you're developing a game on top of blockchain. It could be lottery tickets that you want to distribute. It can be financial assets like shares in a company, or it can be directly a currency like USD or Ether or any other. It can be some measurement of gold and many more. Like anything that you want to store on the blockchain can be represented as a token. Okay, so this is just a general definition of what is a token. Next, moving to what is ERC20 token. So the ERC20 introduces a standard for fungible tokens. So this is ERC20 directly is not a token, it's a token standard. So what is this standard? So this consists of properties that make each token exactly the same. When I say exactly the same, it may be in type or the monetary value as another token. So if I say one ETH in account 1 or one ETH in account 2, one ETH carries this is of the same type and it carries the same monetary value. So I just put in a very basic example here which says that if you're using or considering Ethereum blockchain and ETH as the currency, it means that one token is and will always be equal to all the other tokens on the Ethereum blockchain. Okay, so the value won't differ. So ERC basically stands for Ethereum request for comment, which is a token standard. Similar to ERC20, which is a fungible token, there is ERC721, which is a non-fungible token or NFT. So an NFT is basically a type of token which you cannot break down into smaller portions and send to different accounts. Whereas ERC20 is a fungible token, which means you can break down the ERC20 token into smaller denomination and send it in portions to different accounts. Similarly, if I have 5 Ether in my wallet, I can send 1 Ether to one account, 2 Ethers to some other account, and so on. Whereas if I have a painting stored as NFT, I cannot break down the painting into smaller denominations and send it to different addresses. So that is the major difference between fungible token and a non-fungible token. So ERC20 is a standard for fungible token. So coming to a little bit information about ERC20. So this was proposed by Fabian Vogelester in November 2015. Basically it's a token standard which implements an API for tokens within the smart contracts. Okay, so if we need to know more about ERC20 tokens, we can go follow the official website which tells about all the functions which needs to be present. Okay, so this is the ERC20 token. The entire documentation for ERC20 token is available on this platform, which is ethereum.org. So from here only I have taken the description, but it consists a lot of information about all the functions, functionalities which should be present in an ERC20 token. So what are the basic functionalities which should be present in ERC20 is the capability of transferring the tokens from one account to another. So if you want to develop your own ERC20 token, you can do that, but it should satisfy all these properties, which is it should have a functionality of getting transferred from one account to another. It should have the functionality of getting the current token balance of any account if I want to check a particular account, how many tokens are present. Next, it should have a functionality to calculate what is the total supply of the token available on the network. So if you are creating your own ERC20 token, you will initially set what is the total supply of the tokens. So if I say 50, which means that as soon as I create a new token and deploy it on the Ethereum network, 20 tokens should be available as an initial supply, which I can use to deploy, which I can use to exchange with some other account, and number of implementations can be done. So if you're writing a smart contract which implements all these methods and events, it can be called as an ERC20 token contract. And once you deploy that contract onto the network, this contract would be responsible to keep track of all the created tokens on the Ethereum network. So if you want to look at what methods are needed, so these are some basic methods that are needed. Let me just scroll down. And these are the basic events. Okay. So we have studied about events in the previous online lecture. Events are a way of communicating any changes which is done to the state variables through the network. So the basic methods which should be presented or should be present in your ERC20 token functionality is your token should have a name, it should have a symbol, it should have some decimal values like conversion of that token to integer value, a function of what is the total supply, function for finding out the balance of every address, and functionality for transferring the token, a functionality from transfer from, like if I can transfer from one address to other, approve, allowance, and many more. Not necessary to implement all the methods, but yes, these are the minimum methods required. Coming to the events, so majorly it requires two events, transfer and approval. So whenever there's a transfer of token from one account to other, it should be emitted and recorded onto the blockchain. And whenever there's an approval, okay, so you can see the parameters which are required. So basically, who was the owner, who was the spender, and how much amount has been spent. So that is the approval event. So if we are writing a smart contract which implements these functionalities, we can deploy that token as a valid token on the Ethereum network. So how do we do this? So there is a platform called as Open Zeppelin. Okay. So you need to go to this Open Zeppelin's contract wizard. Okay, I'll paste this link in the chat box so you there so that you can access it. Okay, so I've pasted the link in the chat box. So you can go and access that. So what is this Open Zeppelin? So Open Zeppelin is a secure open source library which consists of lot of APIs which you can directly integrate with your smart contracts and do a lot of functionalities in a secured way. Okay, so instead of writing your token from the scratch, we can use Open Zeppelin to create either an ERC20 token or a 721 token or an ERC 1155 token. Okay, so this developing your own ERC20 token with the help of Open Zeppelin is quite easy. What you need to do is, as said, that the token should have a name, it should have a symbol, it should have a pre-mint value. So what is pre-mint? Pre-mint the value that you set to any number. It is the initial amount of tokens for the deployer. Whoever is deploying will get that much number of tokens. So if I make the pre-mint value to 20, so you see automatically the code is getting added on the right side window, which is automatically creating the mint function. Okay. So there are two major functionalities when you talk about ERC20 tokens is burning and minting. So these are two different functionalities. There are more features as you can see here. We'll talk about each and every feature. So first thing is you need to give a name to your token. So you can give any name. I can give my name to my token. So as soon as I give my name, you see the token name is getting added and the code for creating this token is automatically updated. You have to compulsorily give a symbol to your token. So I'm giving it as DM and I have given a pre-mint value, which it automatically converts through a formula into decimal. Next, I need to add features to this. So depending on what is the requirement of creating this new token, I can decide on what features I want in my token. So these are the listed features I can add. First is mintable. So what is the meaning of mintable? So if I make my token mintable, it means that I give access to some accounts who will be able to create more supply of these tokens as and when needed. So if I check this, automatically the code for making the token mintable gets added here. Okay, so you can see here automatically the function mint has been added. So from which address I need to allow to make to have the capability of minting new tokens, I have to add, and then how many tokens I want to add is to be provided. And you can see that the modifier used here is only owner. So we have studied about modifiers, that modifiers are used for restricting access to functions. So if I deploy this token onto the network, not everyone should be able to create new token supply. Only who is the owner of this smart contract should be able to create more supplies. So in this way, I am restricting the access of minting to only owner. Okay. So as you see that I go on adding features, the code automatically imports certain libraries which are present in Open Zeppelin. So you can see that ownable is a library and this is the path where it is present. ERC20, I'm creating the token. That's why it is already imported the ERC20 solve file, which has all the functionalities written for burning, minting, giving the name already. And I'm just importing those here. And that's why I can use these functions which are present. ERC20 ownable, ERC20 permit. So this I'm directly calling from the paths which have been imported here. Next, you can make your token burnable. Burnable means whoever is the owner or the token holders will be able to destroy their tokens if they want to. Okay. Similarly, if you want to destroy a smart contract, there's a predefined function called as self-destruct that can be used for destroying it. If you want to make the token burnable, you need to click on this. You see automatically a library for burnable functionality is imported. Okay. Similarly, you can make all the features, or as needed, we can add as many features to this newly created token. So next feature is pausable. So specifically given access rights, accounts will be able to pause the functionality marked as when not paused whenever it is needed. Similarly, there is a callback, pre-mint, and flash minting. Okay. So what is flash minting? So there is a capability of making your token built in for giving some flash loans, which means that lending tokens without requiring any collateral as long as they are returned in the same transaction. So you're lending the tokens and those tokens get reverted back during the same transaction. So that can also be added, flash minting. If you go to other functionalities like cross-chain bridging, we are not going to take because it's an advanced concept. Coming to access control. So you can define what kind of access rights you want to give to your token, like ownable, roles, and managed. So we are going to perform the entire assignment for ERC20. Not the assignment, but yes, in order to understand the functionality better, we'll just run this entire code in Remix and deploy this newly created token onto the MetaMask.